Hello viewers, welcome in this video session. Here we'll discuss about the properties of vectors. The property number 1, if A and B are two vectors where vector A is equals to A1 I cap, A2 j cap, A3 k cap, and vector B, B1 I cap, B2 j cap, B3 k cap, defined two vectors. Now how to add them? So when you add two vectors A and B, we'll do the adding of the components. Here the components of I is A1 and here the components of I is B1. So we'll add up A1 plus B1 whole into I cap. And then A2 and here B2. So we'll add up A2 plus B2 into J cap and then A3 and B3. A3 plus B3 into K cap. So now let's set an example here. So here A is equals to I cap plus j cap plus k cap and vector B 2y minus tj plus k cap. So when you add up A and B, what we'll do? The coefficients of I is 1 and here it is 2. So we'll add 1 and 2 into I cap. Then here the coefficient of j cap is 1 and here the coefficient of j cap is minus 3. So 1 minus 3. So this becomes minus 2j. And then coefficient of k cap. In case of vector A, it is 1. In case of vector B, it is 1. So we'll write 1 plus 1 into k cap. So that is 2k. So we are getting the addition of two vectors A and B is equals to 3i cap minus 2j cap plus 2k cap. In the same way, you can do the subtraction also. So in case of subtraction, A minus B will do the subtract of A1 and B1, subtraction of A2 and B2, and subtraction of A3, B3, which are the components of I, J, K in between two vectors. Now, the property 3, the equality of two vectors A and B. When two vectors are said to be equal, if their components of I, that is A1 is equal to B1, component of J, they are A2 and B2 are equal, and component of K, A3 and B3 are equal. Now, when you multiply, the property 4, we are multiplying M is a scalar quantity like 2, 3, half or anything, with the vector A. So, it will be multiplied with all the components of I, J and K. So, we are writing M into A1 whole into I, M into A2 whole into J and M into A3 whole into K. Suppose we are multiplying with 2. So, it will be 2 into A1, 2 into A2, 2 into A3 into K cap. So, now two vectors A and B are said to be collinear. So, collinear means they lie on a same line. Otherwise, in a case of vector, if two vectors are parallel, then also it is said to be collinear. So, mathematically, this is the result, because visually we are understanding that these two vectors are parallel or these two vectors are collinear. Into how we will identify from a mathematical relation, that is very important. So, this is the relation that vector B would be lambda times of vector A. So, B1 and B2 and B3 k cap will be lambda times of A1, lambda times of A2 and lambda times of A3. So, if you write these components I, J, K separately, so B1 will comes to lambda times of A1, B2 is lambda times of A2 and B3 is lambda times of A3. So, that is A1 by B1 is equal to A2 by B2 is equal to A3 by B3. That is A1 by B1 is equals to A2 by B2 is equals to A3 by B3 is equals to 1 by lambda. So, that means we can say that components, if they are proportional, their ratios are same, then the two lines are said to be parallel or collinear. Now we'll find if there are two vectors A and B, how we'll find the direction ratios and direction cosines of the vector AB. Direction ratios and direction. So first we'll take the origin of reference O, and we are taking two vectors along OA, the vector A, along OB, the vector B, and we want to find the direction ratio and direction cosine of AB. So how we'll define? First we'll define the vector AB, and that is equals to OB minus OA. That is B minus A. And if we take the components of B as B1 I cap, B2 J cap, B3 A cap, A1 I cap, A2 J cap, plus A3 A cap. So components of I, here it is B1 minus A1, components of J cap, B2 minus A2, then B3 minus A3 whole into J cap. Now we are able to say that these are the direction ratios. So direction ratios of AB are B2, B1 minus A1, B2 minus A2, B3 minus A3. To find the direction cosines, we need the magnitude of AB. That means cosines are B1 minus A1 by magnitude of AB, B2 minus A2 by magnitude of AB, and B3 minus A3 by magnitude of AB, where magnitude of AB is equals to root over B1 minus A1 whole square, B2 minus A2 whole square, B3 minus A3 whole square. Do you understand why we are dividing by magnitude? As we learn, you know that unit vector, this is the unit vector, components of unit vector. For a unit vector R cap, we require R by magnitude of R. So this is our vector R. This is the magnitude of R. We are getting to L and N. So L is equals to this. This is our L. and this is our m, and this is our n, and you can verify that L square plus m square plus n square is equals to 1. So we are getting this result, L square plus m square plus n square is equal to 1. Oh, sorry, and this is j cap. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.